CTW here, and in this video we're just going to focus on one of the new features, rod force multipoint. So you should be aware of the rod force that we've been doing on both crank dynos and linear actuators up until this point, but now we have the rod force multipoint in the linear actuator, and it is a very powerful new tool, and we're just going to go through and explain to you how to use it so that you can basically start to remove the spring data from your damper. Now, in bicycle dampers, motorcycle front forks, there's a lot of spring effect in there. You can even have situations where you have a large shaft diameter or a very small nitrogen chamber that increases quickly as the damper is compressed. So what you have is a very quick buildup of internal spring force trying to push that shaft out. So maybe at bottom dead center you have X number of force, maybe 10 pounds or 20 newtons. But if you compress the damper 3 inches at top dead center, that increases dramatically, maybe twice the force or 3 to 4 times. And that's where a rod force, just a rod force number, does not do the trick to get the data to look right, because you have a big spring component in there. And I'm not sure, let's see what I have here. Okay, so you have this force versus displacement. So if you have a large spring component in your damper, instead of these mid-stroke being close to zero, the damper, if you've ever seen the curve, look like it starts to rotate so that it's higher on the right side and comes down lower on the left side. That is more than likely because you have a spring in it. It actually is, that spring is adding force based on going from bottom dead center to top dead center. It's actually adding just a static force that gets more and more, and really can make trying to read the graph very confusing. So in order to help remove that spring force, we're going to use this rod force multipoint test and show you how to build it in here so that you can get rid of that and just be looking at your dynamic valving and whatever effect that dynamic spring has, but you'll be removing the static component of it, which is very helpful. So you add the rod force multipoint to your test. You're used to the rod force, you add this instead. And what we have is a position start, reversal, settle time, speed to move point to point, and a table. So the position start would be what you would consider bottom dead center of your test. Position reversal would be top dead center. Now see, this is, it even tells you down here, the position to which to move between the test points to reverse valving. Position start is the very bottom. So if you were running a 2-inch stroke, or even say, let's say you were running a 3-inch stroke, you got a big fork in there, and a 3-inch stroke, you would start at a 1/2 inch, and that is from zero. So the actuator always starts from home. 1/2 inch means it's up 1/2 of an inch, and the reversal was 3.5. So that's the idea that you're running a 3-inch stroke total. So 3 inch plus a 1/2 is 3.5, obviously. So that is the bottom and the top. So if we come in and build our table, I already had one in here from the test before, but we'll say let's go to 7. Into 7 points, calculate positions. This is a table that the software generates to use so that it's going to take a measurement at every one of these positions. First in the compression direction, then it's going to turn around and then come back down, do the same measurements in the extension direction so that it has force readings both ways at the same point. So you can see you build this table, and that's what the machine will actually do. The test I've actually run, to give you an example, only has 5, so I'm going to go back to that so that it makes more sense. 2 seconds is how long it will pause at each one, and 1/2 inch per second is how quickly it will move from point to point. You don't want to move very fast. You do not want to, especially in a very low bleed damper, you don't want to move fast because you're building up internal pressure and settling is if there's a lot of internal pressure, 2 seconds may not be enough. Certainly if there's no bleed, it can't equalize in that amount of time, so your rod force multipoint will not be as effective. So you want to be careful and watch these if you can. So that's the table we build, and I'm going to show you what it would look like on here. So this was what a multipoint would look like. So we kind of move this over. You see your 5 points, and of course these are our 5 points. So that start position, I had a start position of 1/2. In this test I ran, I think my start position was 1/8 of an inch, and you see based on the table that the software created, it moved up and did a pause, moved up, did a pause, moved up, did a pause, etc. That's the position reversal. That's this number here. Then it paused on the way back down. And what it's doing is it's taking a force reading right about here, adding them together, dividing by 2. And it's going to make a point by point by point. So if you think about position and force, it can be some kind of a curve that the software is going to generate, and it's going to remove the force based on position from your data. That way, if you have a spring in there, it will try to remove the spring because the spring makes more force the further you compress it. It will try to remove it from your data based on position. So it's very handy. You no longer have to take your damper apart, take the spring out, run it, and then put it back in, and then hope you did it right. This way you can run it with the spring or rubber or large gas bag, tiny little nitrogen chamber, anything that gives you a big change from bottom dead center to top dead center. This is what you're going to use to get that out, so you can just look at the dynamic valving, and that's really the key. So that's what this test does, this feature command does, this rod force multipoint. It allows you to do that. Add it to your test, use what we've gone through here, and you should see results. You can actually in the end, you can do a back-to-back. You can run with and without. If you have test data, I'm going to do this, and you have your rod force button on. If you have run a multi-point rod force and you uncheck this, it will actually put it back in, and you will watch your, in here I didn't do anything, so nothing's going to look, you see it just goes up and down, which doesn't do much for you, but you can see kind of moves it up and down. So the rod force multi-point, you uncheck this, it'll put all that in. You actually watch your force first displacement rotate up on the right, down on the left, because that spring force will go back in there. So you can actually prove that it is doing something, it is working, and trying to just get you the dynamic data that you're really after. That way you don't have to take your shock apart, and that is the key. So go ahead and reduce that. That is what the multi-point gas test does. There you go. I hope you use it. I hope you get a lot of use out of it and able to get to your end result quicker. There you go. See you later.